And now we are ready to study how our last transformation will be applied on our trig function. So let's start out with sine of x right here. And sine of x is here. And so the graph for the base units of sine of x is here. And it has an amplitude being 1. The wave height from the center line to the vertical distance from the center line to the high peak, or that same vertical distance from the center line to the bottom peak here. So once again, amplitude is 1. The period of this base unit of our standard sine of x function is 2 pi period. And we have a center line for this shape at the line y equals 0, or namely the x-axis. So all that information is here. The start of this base unit is at x equals 0 on the x-axis. And this base unit ends at x equals 2 pi. And so that's every highlighted information about the graph of the standard sine of x being listed here. And throughout the rest of this video lesson, just like the earlier video lessons, I am going to keep this list here permanently on the left hand side of our board, so that later on when we learn the other transformations, we're going to have a clear picture of how the transformation changed the graph of sine of x from the beginning standard original one right here. Alright, and so the next transformation we want to learn now is that let's start out with having a b value being a positive value. And now we would like to study the transformation where our sine function takes the expression x minus b instead of the usual x right here. So to study and to observe how this expression changes from our original sine of x right here, let's look at a little demonstration example right here. So let's look at sine of x minus pi over 2. And so looking at our expression inside of our sine function right here, it is x minus pi over 2. So immediately we can recognize that our b value being a positive value, it's a positive pi over 2 right here. So something to note in mind. And now we are ready to see the graph right here. So right here is the graph of, once again, the original standard sine of x. It has that period being 2 pi. It has a center line at y equals 0. It has that amplitude being 1, the wave height. That's another name for that. It has a start at the base unit here of our sine of x, standard sine of x. Starts at x equals 0, and it ends at x equals 2 pi. And so let's now put up the graph of sine of x minus pi over 2. So here it is. So this graph in blue now is the graph of sine of x minus pi over 2. So let's make some observations here. As far as the shape, the fundamental shape, this graph in blue has the exact same shape as the shape of the graph in red right here. And the next thing is, as far as the wave height, or formally the amplitude of this wave in blue right here, then it looks like the high peak here hits exactly at the same height. And so, and also for the bottom peak right here, from where the center line is, this graph in blue also hits down to as low as the same with how the red graph was hitting. So now we can say that the amplitude for this blue graph right here, this blue graph has amplitude the same as the original sine of x, being 1. This graph in blue right here as well still has that same center line with the graph of sine of x in red here. They both have the same center line. And that center line is the line y equals 0. So let's go ahead and list it down. The center line, or like I remind again, that sometimes some textbooks call that the midline. Here it's the line y equals 0, or namely the x-axis. And now let's look at the as far as the length right here of the whole wave, the entire wave. So it's what we saw here is that this wave seems like the wave in blue right here seems like it maintained the exact same length interval for the complete base unit right here, and compare that with in comparison with the red graph right here. So I can see that period remains the same as the standard sine of x function. But now starting point, we noted some difference in the starting point right here. This graph in blue right here, our base units for sine of x minus pi over 2, it actually starts at x equals pi over 2 right here. So the start is at x equals positive pi over 2. And then the ending here is at x equals 5 pi over 2. And so that's what reading out directly the coordinates right on the graph right here and on the x-axis. That's what we noticed right here through observation. And so let's check for some consistency. So we made our conclusion earlier that period for this graph in blue here is being a 2 pi right here, and it has a start at x equals pi over 2, and it has an ending at x equals 5 pi over 2. So if we can do a little quick math right here, remember the whole idea about the period is that total length between the start and the end. So if we take the end point being 5 pi over 2, and we subtract the starting point pi over 2 right here, we ended up with 4 pi over 2, which in turn reduces down to 2 pi. So in this case, this is perfectly consistent with what we concluded through observation earlier, that our period on this blue function is, on this blue graph right here, sine of x minus pi over 2 is a period 2 pi. And so now looking at this picture, this entire picture of the blue graph, and compare that with the entire picture of the red graph right here for the original sine of x function, then it looks like the exact same image, the exact same picture here is being pushed or being shifted to the right hand side, on the x-axis by a distance of pi over 2 distance. So see, from the end point originally being 2 pi, now it's being shifted to a 5 pi over 2, and it's all due to that start point being different here. So another conclusion, another generalization we can put down for this particular function, that it looks like, through observation, that it looks like the graph of sine of x is being shifted, and allowed me to use this right arrow pointing to the right hand side, indicating we're shifted horizontally but to the right hand side by a distance of pi over 2. And let's study again the same transformation but on a different function right here. So let's quickly investigate what about y equals sine of x minus pi over 4. And so immediately before we proceed here, then we can notice the b value in this expression, x minus pi over 4, is that value positive pi over 4. Because remember, we permanently set b value being positive, and we would like to see our function here in the form of sine of x minus the b value. And so, once again, on our graphing device right here, the original sine of x function is here. And we already knew by heart now that it got amplitude, one center line at y equals 0, and with a period being 2 pi. And here it is. The graph in blue here is the graph for sine of x minus pi over 4. So what we see here, once again comparing the two graphs, what we notice here, the graph in blue here, the base unit of our sine of x minus pi over 4, it has the same wave height with the red graph right here. And the red graph once again came out from the original sine of x. And so we can draw that first conclusion, that's amplitude. On our function sine of x minus pi over 4 here is 1 again. Same wave height. And also we can see that center line, they are both staying on the same center line. The blue graph and the red graph right here, they both stay on that same center line. In this graph right here, it's the x-axis. So the line itself is with the equation y equals 0, but namely the x-axis. And now the period in this case right here, well, for now it's simply as far as the eyes can tell us, then it looks like the blue graph right here has the exact same interval length from where it starts to where it ends right here. The interval length here is exactly about the same, seems like about the same with the interval length, the periods of that of our graph in red picture. And so right now it's just a prediction. So we're predicting that the period for this sine of x minus pi over 4 is a 2 pi period, and we will come back to confirm that later. And now on this graph right here, it's looking a little on this graph right here, it's a little challenge to see where the start and where the end is. So now putting the graph in a closer zoom, then we can see it a much more clear picture of in terms of where the blue graph starts and where the blue graph here ends right here. And so our function sine of x minus pi over 4 has a start at x equals positive pi over 4 this time. And it has an end. This blue graph here has an end at x equals 9 pi over 4. And so after two little demonstration examples right here, then start looking at how the start of our function here being related to the value b inside of our sine function. And so now after recognizing the start and the end of our blue graph right here, then we can once again take the end of our base unit, 9 pi over 4, quickly subtract pi over 4, the beginning, the start of our base units right here, and the math turns out 8 pi over 4, which in turn equals 2 pi. And so this is now confirming that our observation wasn't wrong. It's the period for this graph in blue is a 2 pi period. And so now generally as an entire picture, then the graph in blue here is the graph of sine of x in red, but being shifted to the right hand side by a space of by a horizontal space of pi over 4, by a horizontal distance of pi over 4 on the x-axis. And so that's another generalization we can find out here. But the graph of sine of x minus pi over 4, it is it's nothing but the graph of sine of x, but being shifted. So in other words, saying the graph of sine of x in this problem here is shifted to the right hand side again, due to that starting point being a positive starting point to the right hand side of the original one. And that's how we can say that it's being shifted to the right hand point, to the right hand side. So shifted to the right hand side by a pi over 4 distance. And again, having our b value started out being a positive value, let's now consider how the graph of sine of x is going to look like when it's sine of x plus b. So the same value b being positive, but the expression inside of our sine function is being x plus b now. And so our literal demonstration example here about sine of x plus 3 pi over 4. And so once again, in this case right here, in our particular little example here, then our b value is 3 pi over 4. All right, and so this is the graph of our original sine of x, the standard sine of x, and we already knew the amplitude as well as the center line, where it starts, where it ends, and it's that, and all the start and the ends making up that and the period for this base unit of our standard sine of x function is being an interval of 2 pi. So here is our function in blue, our function of sine of x plus 3 pi over 4. And so now, quickly observing this, you can see that the shape once again remains exactly the same here. So we have the same shape. The wave here hits to as high as 1, and the wave for this blue graph also hits down to as low as -1, just like the standard sine of x. So our first thing that we can list down here is the amplitude of this function remains the same as the original sine of x. Our center line or many textbooks also refer to that as the midline. Our center line is here on the x-axis. So the blue graph here has the same center line with the original standard sine of x right here. So center line is y equals 0, or namely the x-axis. All right, and let's now look at the period. So with our current graph right here, and of course some grids on the x-axis are being hidden right now, but we can estimate that the period for this blue graph, which is also the base units of our sine of x plus 3 pi over 4, this period seems like we're being estimated to be about 2 pi again, because it does look about same length with our graph in red right here. And then we will come back to confirm that. And now in a closer zoom where all of the grids can be successfully displayed right here, then it looks like we have a start. Our blue graph right here has it starts at x equals -3 pi over 4. So that's what we recognize through the observation. So we have a start at x equals -3 pi over 4. Start noting how the start value of our base units on the blue graph being related to our b value. We also recognize that the end of our blue graph here is at x equals 5 pi over 4. So now just a moment ago I was saying that the period for our graph here is being estimated to be 2 pi, because it's at that point it's just simply looking like about the same as the period on our original sine of x. But now having the start and the end point successfully nailed down right here, let's do a little quick math again. But we're looking at 5 pi over 4 at being our end of the blue graph. We're going to subtract -3 pi over 4 being the start of our blue graph, and the math here gives us 8 pi over 4, which in turn reduces down to a 2 pi. And so now that confirms our period here must be a 2 pi. And then one more time, generally speaking, as a whole, looking through the two graphs here as an entire picture over here, then it looks like the graph in blue is the graph in red, which was the graph of the original sine of x. And so blue is the graph of sine of x, but being shifted by due to the starting point being at negative 3 pi over 4. And so as another general conclusion, we can see that the blue graph here as a whole picture is exactly the graph in red for here for sine of x, but being shifted to negative 3 pi over 4. Or in other words, it's being shifted to the left by 3 pi over 4. And so we can say that in this function, sine of x plus 3 pi over 4, when we're graphing that, it looks like the graph of our original sine of x is shifted. But this time to the left hand side by the quantity of 3 pi over 4. So how far spacing for the shift here is always a positive value, but this time we're shifting the graph to the left hand side, and it's once again it's all due to that nature that the start's now being at negative 3 pi over 4. And let's now formulate a generality on those functions. Once again, starting out with b being a positive value, those functions sine of x minus b or sine of x plus b. What generalities did we draw from throughout our investigations? They all have the same amplitude with the original sine of x function. So amplitude 1. They all have the same center line with our original standard sine of x. So the center line is on the x-axis, y equals 0, namely the x-axis. They have a period. They all have the period being the same with our original sine of x. So it's a 2 pi period. However, the start point is going to become different. So the starting point for our function will be x equals b, same b with that b value. It's going to be, it starts at x equals b when our function is sine of x minus b. So this is the part where a lot of time it looks quite counterintuitive for a lot of people learning this. But so when it's minus x minus b inside of our sine function, then the trick graph actually starts at x equals positive b, right there, or being shifted to the right hand side. So another way of saying that, the graph of sine of x shifts to the right hand side by how far? By b units far. B units. And the graph is going to start at minus b when the function is sine of x plus b. So two different cases. And so obviously in this case right here, the graph, it's the same as saying the graph of sine of x shifts to the left hand side by how far? By b units. And the end of our base units on this function, on any of these functions, sine of either x minus b or sine of either x plus b, is always where we have the start value plus with a 2 pi period. So that's how we recognize the end right here. Now, on our cosine of x function, here's once again the graph of cosine of x. And as a brief reminder, it has an amplitude. This wave here has an amplitude being 1. It has a period from start to end here being a total period of 2 pi. The center line of this standard cosine of x is on the line y equals 0, which is namely the x-axis. And it has a start at x equals 0, and the basic unit has the end at x equals 2 pi. I am now going to once again leave this information of our cosine function permanently on the left-hand side of our board throughout the entire video lesson here. And let's now look at how the last transformation can be applied on cosine throughout a few different various examples here. So, starting out with a value b again being positive. And this time we want to investigate how this function cosine of x minus b will change the graph compared to the original graph of cosine of x. And so the example we want to look at here for our first demonstration is y equals cosine of x minus pi over 2. And so before we move on any further, once again, so here we need our b value to be a positive. So in this setting right here, x minus pi over 2, then quickly we can recognize that our b value in this problem is the pi over 2, positive pi over 2. And so now on our graphing board here from decimals, the red curve here is the graph of y equals cosine of x, the original cosine of x. And here it is. The graph of cosine of x minus pi over 2 is here. The graph that is in blue. Now let's have some observations on this blue graph right here. So as far as the fundamental shape, comparing with the original cosine of x, then this blue graph has the exact shape right here as well as orientation. And so wave height from where the center line is, this blue graph reaches down to as far as -1 and reaches up to vertically as far as +1. So amplitudes remain exactly the same with our original cosine of x function. So now we can start listing down the amplitude of this blue graph is 1. This blue graph has a central line being at that line of y equals 0, or namely the x-axis. So the center line of this blue graph is the line y equals 0, or namely the x-axis. And now looking at the period here, this one base unit of our cosine of x minus pi over 2 has a start here about pi over 2. It has an end at about 5 pi over 2, and I will list that out at the end right here. But so in the way how it looks right now, we can estimate that the period of this blue base units here is going to be, and it looks about just exactly the same with the period on the base units for cosine of x. And so here we can estimate that the period of this function cosine of x minus pi over 2 is being a 2 pi. And like I said, we will come back to confirm this estimated value right here for the period. But so now obviously since the grids are here on the, since the grids are being displayed here on the graph right there, then it's making it clear that our blue graph here has a start, or the base unit of our cosine of x minus pi over 2 has a start recognized at x equals positive pi over 2. And the end of this base unit on our cosine of x minus pi over 2 is at x equals 5 pi over 2. And so in this way, start making a note of how this value of the start is being related to the b value in our function. And then in the end, as an entire picture right here, then the graph in blue, which represent the base units of our cosine of x minus pi over 2, is exactly the graph of the original cosine of x, but being shifted to the right hand side by a horizontal distance being pi over 2. And so another general conclusion, we can say that this graph of cosine of x minus pi over 2 is exactly the graph, or it's making the graph of cosine of x to be shifted to the right hand side again. And by how far? By horizontally a pi over 2 distance. As a different demonstration example, let's now look at cosine of x minus 3 pi over 4. And once again, in this setting right here, inside of our cosine function, we recognize the expression x minus 3 pi over 4. So apparently that our value here is being 3 pi over 4. That's something to note about this expression inside of our cosine function. And so once again, back into my graphing board here with decimals, cosine of x is here. And once again, permanently in red color throughout any of our video demonstrations here. And here it is, the graph of cosine of x minus 3 pi over 4. And so, since the grids currently are not being able to display the start and the end, we will get to that a little bit shortly. But let's find out the information that's easy to capture here throughout our observations. So, observation is telling us that this shape of the blue graph, which is the base units of our function cosine of x minus 3 pi over 4, remains exactly the same as the shape of that red curve being the base unit of our original cosine of x. And as well as amplitude or wave height, this blue graph has the wave height being just about the same as the wave height of our red graph right here. And so general conclusion about the amplitude, cosine of x minus 3 pi over 4 has amplitude being 1. The same amplitude with the original cosine of x. Center line. And once again, looking back at our picture right here, then the blue graph right here has the same center line with our graph of original cosine of x. And that center line here is the line y equals 0, or namely the x-axis. And so another generalization to list down here is that this function has center line y equals 0, or namely x-axis. And now let's get to the period right here. So as an estimate, it does look like that our blue graph has the same length from the beginning to the end of our wave, even though we're not currently clear where the start and where the end of our blue curve is yet. But it's apparently clear that we can estimate that this wavelength in blue has period 2 pi. So the period is estimated to be 2 pi. And we will come back to confirm with that after we nail down the actual, after we recognize where it starts and where it ends right here. And so now in a closer zoom right here, then our blue graph with the grids being displayed with my decimal graphing board right here, then the blue graph appears now that to have a start at 3 pi over 4. And it has an end at 11 pi over 4. And those 2 points, the starting point and the ending point, make up our complete base units of the cosine x minus 3 pi over 4. So what we recognize now is that the start of our base units on this function is at x equals 3 pi over 4. And once again, make clear note of how this start is being related with our b value 3 pi over 4 right there. And our end here of the base unit is at x equals 11 pi over 4. So now we can confirm that at the end here being 11 pi over 4, we can subtract our start of the base unit on this blue graph, and that's going to produce 8 pi over 4, which in turn reduces down to 2 pi. And that is once again confirming our period no longer now being an estimate, but solidly being a period 2 pi. And again, looking back into our picture over here, then as an entire picture, comparing the blue graph and the red graph right here, then so what it shows here is that the blue graph truly is the graph of cosine of x, but being shifted to the right hand side by a horizontal distance 3 pi over 4. Okay, and as another generalization, we see in this graph of cosine x minus 3 pi over 4 is that the graph of the original cosine of x is shifted to the right hand side by horizontally 3 pi over 4 distance. And then let's look at the graph of the function cosine of x plus b. And once again, starting out, letting b being a positive value permanently. And so a little demonstration example I can bring up here is cosine of x plus pi over 4. And so in the way how it looks here, once again, the setting is x plus pi over 4. And the setting, I mean the setting of that expression inside of our cosine function. So x plus pi over 4 is once again our b value is still being a positive value. And here it's positive pi over 4. But the setting, once again, the setting inside of the expression inside of our cosine of x, cosine function is x plus pi over 4. And so once again, back on my graphing board here with decimals, then cosine of x is here the standard original cosine of x. And now cosine of x plus pi over 4. Here it is. This graph in blue right here. And so looking at the graph here, you can see that shape remains exactly the same as far as the shape right here, and amplitude, this wave here in blue hits as high as 1 and hits as low as -1, just exactly the same with our red curve right here. And so now our first understanding is that the amplitude remains the same with the original cosine of x, amplitude being 1. The blue graph here has a center line. The center line is right here on the x-axis on my graph. So that center line, once again, the line y equals 0, or namely the x-axis. Just like the original cosine of x function. And then for period, and once again, in this particular graph right here, my graphing calculator, my graphing board on Desmos is not currently showing the detailed grids that displays the start and the end of this blue graph right here. But just simply by looking, we can estimate well enough that the period here for this blue graph should be the same with the period of that red graph right here. And so as an estimate, the period of our current function cosine of x plus pi over 4 is a 2 pi period. And now putting our function into closer zoom, where Desmo is now able to put up the start and the ending grid of our blue graph right here, then we can recognize through observation that our blue graph, the base unit of our cosine of x plus pi over 4, has a start at x equals negative pi over 4 on the x-axis. And on the other hand, it has an ending on the x-axis at x equals 7 pi over 4. And so now I'm going to list it down. The start of our blue base units of cosine of x plus pi over 4 is at x equals negative pi over 4. And it has an end on the x-axis at positive 7 pi over 4. And so in that way, before we move on further, then let's double check and confirm to see if the start and the end here are consistent with our period. So on the graph, it shows that our ending is 7 pi over 4. And now simply subtracting the starting point minus pi over 4 from the ending point, we are ending up with 8 pi over 4, which in turn reduces down to 2 pi. And this is now perfectly consistent with what we estimated earlier, that our period was estimated being 2 pi. And finally, again, this graph of cosine of x plus pi over 4, graphically on our Desmo here, it's a blue graph, is, as far as the picture, it is exactly the red graph for the original cosine of x, but being shifted to the left-hand side by a horizontal distance, pi over 4 distance, but to the left-hand side. That's why the starting point was at negative pi over 4. And so another generality we found here, another general conclusion we found here is that when we are graphing this cosine of x plus pi over 4, the graph of the original cosine of x is shifted to the left by horizontal space pi over 4. And that's how we recognize, particularly in this function. And now formulating a generalization on those functions, either y equals cosine of x minus b, or y equals cosine of x plus b. Again, setting b is the value being a positive value. Then any of these graphs right here, throughout our investigations previously, they always had, any of these graphs had amplitude being 1, just like our original cosine of x. Any one of those graphs has a center line at y equals 0, or namely the x-axis. And any one of these graphs right here has a period 2 pi. And once again, just like the original cosine of x. But when it gets to the start of the base unit right here, then the start here, the start is x equals b when our function is y equals a cosine of x minus b. And in this way, we understanding the graph of this cosine of x minus b is the same as the graph of the original cosine of x, but shifted to the right hand side horizontally by b units. And any one of these functions, then the starting point is going to be x equals minus b when our function is particularly cosine of x plus b. And this is where it's becoming a little counterintuitive that the expression inside of our cosine function is x plus b, but the start point is at x equals negative b. So, and another way of thinking is that the graph of this cosine of x plus b is the same as the graph of cosine of x, but being shifted to the left hand side by b units horizontally. And our ending point on the base units of any of these functions is simply rule of thumb at the start point or the start value, add the period 2 pi, and that's where it ends. And so, as a generality, on this very last transformation we've just learned, then let f of x be a function either sine of x or cosine of x, the standard sine of x or cosine of x, and provided that a value b is a positive value, then generally f of x minus b is going to change the starting point starts of the base unit to x equals b. And when either our function sine of x or cosine of x takes the expression x plus b, then this will change the start point changes the start of our base unit, the base unit to x equals minus b.